Hello dear students, I welcome all of you into the video solution plus discussion for Aiats 2 conducted for 12th passed students on 30th of November 2025. Let's look at the first question. The first question says P vector plus Q vector equal to R vector, right? And we are supposed to find the magnitude of vector Q, right? So what we are going to do is leave vector Q on one side. So this will become Q vector is equal to R vector minus P vector, right? Now let's multiply both sides by taking the dot product with Q vector, right? So this will become Q vector dot Q vector. On the LHS and on the RHS you multiply it with Q vector, right? Like this by taking the dot product. So this will become R dot Q minus P dot Q, right? And remember Q vector dot Q vector, we know dot product of a vector with itself will give the square of its magnitude, right? So this will become mod Q vector whole square, or we can simply write it as Q square, right? Q square is equal to R dot Q minus P dot Q, right? And we are supposed to find the magnitude, which will be nothing but take whole under the root, right? So Q is going to be whole under the root R dot Q minus P dot Q, right? And as you can clearly see in the options, this is going to be option 3, right? Other options, they are negated. Option 4 is clearly wrong, right? Because it's written R dot P. Okay, so let's look at the correct answer. And yes, 3 is correct. Coming to question 2 now, this one says a 2 kg block is kept in equilibrium with the help of strings as shown. The value of tension in string QR will be, right? So if you see tension in string QR, let's say it is T2, okay? So here you have T2, and let's say in string PQ the tension is T1, right? It's something like this. So let me draw a separate diagram over here. So this is Q, right? And remember they are in equilibrium, right? So which means what about this string? In this string, right? In this string the tension is going to be 2 into G, right? Because on the 2 kg block, let's say here tension is T and here it is mg, so it's simply 2G, right? So we can also draw it like this. I'm writing T over here. So if you see over here, this becomes T2, right? And as you can clearly see, this angle has been given to you, right? Which means this angle over here, the angle that tension T2 makes with horizontal, it's going to be 37 degree, right? And the downward tension is T, which is equal to 2G. So I'm simply writing it as 2G. And towards left, you have your T1, right? And since it's given that they are in equilibrium, so if we resolve these forces, right? So here you will get T2 cos 37 degree, right? And towards the top, you're going to get T2 sin 37 degree. So we can clearly equate the forces along the vertical. So this is going to become T2 sin 37, which is 3 by 5 equal to 2 into G, and 2 into G is 20, right? So if we solve for it, you will get T2 which is 20 into 5, 100 upon 3 Newton, which is given to us in option 4, and the rest of the options are clearly wrong. Let's look at the answer slide, and yes, option 4 is correct. Coming to question 3 now, this one says a body is moved along a straight line by a machine delivering constant power. The kinetic energy of the body is proportional to time t as. So remember my dear friends, power is nothing but the rate of change of kinetic energy, right? So rate of change of kinetic energy, power is given to be constant, right? So which means dk constant, let's say I'm calling it as c, it is equal to c dt. If we integrate both sides, what you are going to be getting is k equal to ct, which is the kinetic energy k is proportional to time t, which means option 3 is going to be our answer. Let's check, and yes, 3 is correct. Coming to question 4 now, it's a statement based question. This one says, statement A, the collision in which the bodies stick together after collision is called perfectly elastic collision. So this is a wrong statement, because a collision in which the bodies stick together, such a collision is called perfectly inelastic collision, right? And also remember that in both collisions, elastic collision or inelastic collision, the momentum will remain conserved. And if you see statement B, it says in perfectly inelastic collision, linear momentum of system is conserved. So this is obviously correct. But statement A is wrong, which means our answer is going to be option 4. Statement A is incorrect and statement B is correct. Let's look at the answer slide. And yes, 4 is correct. Question 5 now. Here this one says, the work done by the force F equal to 2I cap plus 2J cap minus K cap Newton when it displaces the body from a point 2, 3, minus 4 to another point 5, 1, 3. Right. So remember, for this question, we can find the displacement vector, right? Displacement vector, let me call it as D vector. It is nothing but the final position vector minus the initial position vector, right? So which means from here you will get the final position vector. From this point you will get the initial position vector. So you have to subtract them. Okay. So final minus initial, right? Which means the I cap component is going to be 5 minus 2, right? 5 minus 2 I cap. J cap is going to be 1 minus 3 J cap. And for K cap, it's going to be 3 minus of minus 4, which becomes 3 plus 4 K cap, right? So this will become 3 I cap minus 2 J cap plus 7 K cap. And the unit of this displacement is going to be in meters. So force is given, displacement is given. Now all you have to do is find the work done by taking their dot product, right? So now we are going to be finding the work done. So the work done is given by force into displacement, right? We are going to be taking the dot product of force vector with displacement vector. So this is going to be, you multiply the I cap coefficient with the I cap coefficient, that is 2 I cap in force vector and 3 I cap in displacement vector, right? So the coefficient multiplication will become 2 into 3, that is 6. Then J cap with J cap, this will become 2 into minus 2, that is minus 4. K cap with K cap, so minus 1 into plus 7, this will become minus 7, right? So therefore the answer is going to be 6 minus 11, which is going to be minus 5 joules, which is given to us in option 2. Let's check our answer slide, and yes, 2 is correct.